Morning, ladies and gentlemen. Thanks for coming to see us at CARIS this morning. We've got members from some special guests here this morning, members of the press, and of course my colleagues here from CARIS as well. So it's a great pleasure to extend a warm welcome to you here at CARIS this morning. And what we're going to do just in a few short minutes here is really highlight the work of the Canadian Hydrographic Service, the important work that the Canadian Hydrographic Service does. And we're also going to touch on the innovation that goes on in the Canadian geomatics industry. That's what CARIS is involved in, and that's what the CHS is involved in, so it's a nice opportunity to highlight some of the innovation that's taking place. So the other focus really, besides highlighting the great work that the CHS does, the Canadian Hydrographic Service does, is to talk a bit about this project to develop 3D printed models of HMS Erebus. And that's something that the CHS, CARIS, and an innovative geomatics company from Calgary has been involved with, called TECTERRA. And you'll learn more about that project this morning. But I've had models on the brain for a while now in the lead up for this. And in fact, I woke up this morning and I turned around to my wife and I said, I've been dreaming about those models again. And she kind of looked at me a bit weird, and I said, the shipwreck models. And she said, that's good, Andy, I'll make you breakfast after all. But anyway, without further ado, I'd like to ask Michel Gauguin to give some remarks about his work and the discovery in the north. Michel is the Regional Director of the Canadian Hydrographic Service for the Central and Arctic region. Michel is based in Burlington, but boards from these shores, I think from New Brunswick, Shediac originally. So quite fitting that Michel is here this morning. And I'll tee up your presentation and hand over to you, sir.
Good morning. First of all, I'm not from Shediac. I'm from Gauguin. For the ones that come from New Brunswick, they know it's Gauguin. It's not Gauguin. My name is Michel Gauguin. I'm the director of the Canadian Hydrographic Service for the Arctic area, Central and Arctic. I'm based out of Burlington, Ontario. You can go up to the first slide. I think you're at the end. Yeah, okay. I'm very proud to say that it was my office that coordinated the seabed mapping portion of the 2014 Franklin expedition. The Canadian Hydrographic Service is a branch of Fisheries and Oceans Canada. It has been an expert in hydrographic surveying, nautical charting, and seabed mapping since we've been in the business 135 years ago. It started out with the SS Asia sinking in Georgian Bay, Ontario. Similar to the time of the Franklin, the Canadian Arctic remains the frontier of our nation. And even today, much about the Arctic sea bottom is largely unknown. For that reason, the Canadian Hydrographic Survey conducts annual surveys and mapping projects in the Arctic in areas critical to navigation. These are performed under challenging environmental conditions and within short windows of opportunity. So if you look at this, we've got part of the chart here. It's kind of hard to see from there, but there's all kinds of what we call whited out areas. Whited out areas is basically where we don't have information. If you look on the southern part, there's not too many of those. In the Arctic, there's all kinds of those. Okay. Next. Because of our expertise, the Canadian Hydrographic Service has been a key partner of Parks Canada search for the Franklin ships from the beginning, in 2008. So you can see all the areas here that have been searched through the years. While Parks' primary objective has been to locate the missing Franklin ships, the Canadian Hydrographic Service has leveraged the opportunity, like we do with anybody else working in the Arctic, to collect new hydrographic information that will be used to improve navigational charts that support safe maritime shipping within the Arctic. Next slide. The Canadian Hydrographic Service uses state-of-the-art technology, such as multi-beam sonar. This is a multi-beam sonar here. The difference, we started with lead lines, we went to single beam, and now we're on to multi-beams. The difference is you get more coverage per pass, so in theory it takes you less time. But in reality, because we have this, people usually want total bottom coverage. and it often doesn't take the best time. Okay, all parts. Slide three. Go back one. Okay. To map, we have multi-beam sonars to map the ocean floor and model the seafloor in 3D detail. The multi-beam sonar transmits hundreds of beams of sound through the water and captures detailed images of the seabed. The high-precision technology can identify hazards and features such as shipwreck on the seafloor. In the 2014 expedition, the Canadian Hydrographic Service temporarily installed and operated multi-beam sonar systems on the Canadian Coast Guard ship Sir Wilfrid Laurier, which is there. We had a multi-beam installed over the side because it's temporary. The CHS also ferries survey launches, the Kinglet and the Gannet. They're there, but they're also shown there, which were deployed from the Laurier. We also installed and operated a temporary multi-beam sonar system on the Royal Canadian Navy HMS Kingston. Due to unfavorable ice conditions, the Kingston was retasked to the Eastern Arctic, where it, along with its crew, undertook the collection of new seabed data in an area of importance for shipping. Next. Worth noting is that during the 2014 project alone, my hydrographic teams aboard the Canadian Coast Guard icebreaker Laurier, Kinglet, and Gannet covered the equivalent of 4,605 line kilometers of seabed, the distance between Vancouver and Ottawa. The Navy's Kingston, also with our multi-beam and our hydrographers, surveyed 2,436 line kilometers, the distance between Winnipeg and Quebec City. This work included expanding existing marine routes to increase the safety margins for shipping through the Arctic waters. So, seems like a lot, but the Arctic is big. Okay, next. The multi-beam sonar was capable of rendering very detailed three-dimensional model of the wreck. The model is in fact point cloud, with each point representing an individual ping, as we call them, from the multi-beam sonar. With subsequent passes over the wreck site by the Canadian Hydrographic Survey launches equipped with multi-beam sonar, the point cloud increases in density. As a result, details and features becoming more readily identifiable. And that's what you see here. This was all done with multi-beam. So it's basically each one of those is a ping, is a measurement, and then you bring the three-dimensional, we call it point cloud, which is basically all the points together, and you make a model of it. Next. As Parks Canada archaeologists have indicated, this high-precision depiction was critical in the identification of the wreck as the Erebus. The model will continue to be a valuable resource for the Parks Canada archaeologists going forward, as they will use it as a planning tool for future missions and as a foundation to build their findings upon. The 2014 project is as much an archaeological success story as it is a story of how effective partnerships can yield fantastic results. With us, if you look at the CHS, most of our work in the Arctic is done through partnerships, and I think almost everybody's work in the Arctic is done through partnerships. Thank you very much.
So this is the video that's been playing out in the lobby there, but you can see the point cloud that Michelle talked about. So this very detailed result of the multi-beam survey that took place up there. So yeah, feel free after the meeting to go back into the lobby and to look closer at the video there, and you'll really see quite some details emerge from this fantastic data set, really. Anyway, next I'd like to introduce Mark Masry to say a few words. Mark is one of our senior development managers here at CARIS, and he's going to talk a little bit about our relationship with CHS and the technology, the innovative technology that led to these models today. Thank you, Mark.
Thanks, Andy. Yeah, I just wanted to say a few minutes to give you a bit of background about our relationship with the CHS and some of the work we've done, and also how the work that we did on our software evolved into the models you're seeing today. So, as some of you may know, our relationship with the CHS goes back a very long way, all the way back to 1979, when the CHS awarded us a contract to produce charting software, which was really around the time of the birth of CARIS and shortly after the birth of me. and we've worked together very closely ever since. In fact, actually, some of the initial software that turned into the first version of CARIS evolved from a CHS internal software project, and that became some of the first software that we ever sold. Afterwards, we've continued our relationship, and we've benefited greatly from the relationship, and so it's almost in a way to say thank you that I wanted to speak a bit about that today. It's been a tremendous benefit to us, and we're very proud to continue working with you. Some of that software in the first versions of CARIS found its way into our HIPS and SIPS product, which is actually the software that was used to produce these images of the wreck and these videos. HIPS and SIPS is a product used to process sonar multibeam data, to do seafloor mapping. It's used all around the world, and it had its inception right here in Canada. When we saw the images that were these images, actually, it was sort of a natural question, given all the work that's going on with 3D printing. Could we take this data and these images and actually make 3D printouts out of them? What would that look like, and what would that take? So we contacted the CHS, and they were interested as well. So we set to work. We actually also talked to a company in Calgary. Andy's mentioned them. It's a company group called TECTERRA. That's a geomatics innovation group that's produced or put together a really world-class 3D printing facility. We contacted them and asked if they'd be willing to and able to print models of a size and detail that we and the CHS would be interested in. They said yes. So we looked at enhancing HIPS and SIPS to be able to produce data of the kind that these 3D printers could take in and use to kind of print this model. So we sent that data off to TECTERRA, these triangulated models, and they were able to actually produce the 3D printed objects that you'll see here today. So a little word about this. About 10 years ago, before I joined CARIS again, I was really involved at research level with 3D printing, and I worked on some of the very first 3D printers that were commercially available. And so this project has a lot of aspects that are kind of near and dear to my heart. But one thing is that it's really hard to explain exactly how far the technology's come, even in that space of time. The 3D printed models we worked with back then were quite simple. They took an incredibly long time to make. They were very, very expensive. The cost of those models has come down a lot more. They're still not cheap, but we can print at a much higher level of detail now, much larger, and also with different materials and in different colors. So the two models that are here today are both printed in two different colors. The CHS's model is in ocean blue, and ours is a brown and green tone model. But what's interesting is that the printer actually prints the color directly into the model. It's embedded in the object itself, like a ceramic tile. It goes all the way through, and that's because the printer works a little bit like an inkjet and layers out the different layers of this model piece by piece, embedding the color as it goes. So it's really a fantastic kind of thing to watch. If you have 12 hours to spend watching it, it's really very interesting. But it's this kind of end-to-end project that I think is an excellent example of the kind of work that Canadian technology can do, and the applicability of Canadian technology to projects like the discovery of the Erebus and even to Arctic mapping. And so we're very glad to have played even a small part in that, and to have been allowed to do so by the CHS was a great honor. So thank you very much, and we're very proud of being part.
Thank you, Mark. So at this point in the proceedings, I'd basically just like to open up the floor if there's any questions about the discovery of the Erebus, about 3D printing. So if there's any questions that anyone has, this is the time. Yes, Colleen.
I don't have particular questions.
So what's the plan for the future? Is there more to be done for the Erebus?
Sure.
The search for the Franklin continues this summer. I think they'll be going there's a north and south search area. So they found the Erebus on the north, the south one. This summer they'll go back to the north. And there's, again, it's going to be a partnership between Parks and D&D is going to be there with some of their ships, Coast Guard and everybody else.
So the interesting thing is, yeah, Erebus is one of two vessels, the Terror being the other. So the search for the Northwest Passage 170 years ago involved these two vessels that were both lost, of course. So yeah, the search continues, I guess, for the Terror as well.
You'll get a bit of both this summer because there's going to be a lot of people on the Erebus diving and getting more information on it, but you'll also have another crew searching on the other side for the other ship.
I think it's also just actually in the next couple of weeks there's going to be more dives taking place and this kind of thing. And actually the emergence of the model has had this added benefit of being able to be used as diver orientation, so pre-dive, to be able to look at the model in real space and say, look guys, let's go down and investigate this piece. It means for quite an effective planning tool, I think. So yeah. Any more questions?
Just wondered, if these divers are going down, are there such things as kind of underwater handheld scanners for the divers to go down and actually scan parts that are kind of invisible at all? I don't know.
I think the technology exists. Whether it'll be used or not, I guess remains to be seen. But certainly there are companies now that have high resolution scanners that you can actually mount on tripods on the sea floor, and they are image scanners that do this sweep, and you can get very high resolution. So that does give you that in proximity image as well from different perspectives and different viewpoints. So the technology's there. I guess at what point it's used will remains to be seen.
I mean, it's also going to depend on the shape of the ship, like, how dangerous is it to go in and things like that.
This ship's in 11 meters of water, though, right?
Yeah, approximately.
Name of that ship, HMS Erebus. As part of the Royal Navy time, is that still technically English property?
No comment, Robert. That's why I'm here as an Englishman.
How large is that ship?
So it was 108 foot long when it was launched, so somewhere around 108 foot. Slightly shorter today after the ice has ripped away parts of it. But this scale model is 1 to 130 scale. So 10 inches approximately of model. Scaled up is about 100, I think around 108 foot long. Stefan.
From a navigation point of view, I suspect those areas are already protected somehow, right? Like, are they marked on the charts as the restricted areas, or do you proceed with caution, or?
Presently, the site of the ship is not on the charts. Okay, we've updated the charts where we had existing information to update the existing information, but the information hasn't been displayed to take you to the site.
Okay.
But over time, I mean, it's fairly new. Maybe this summer something will probably be put in place.
Any more questions? In that case, I'd like to thank everyone for coming this morning. Please feel free to get a coffee in the lobby, take a look at the models that are there, chat to Michelle and the CARIS experts as well, and just thank you all for attending, and have a great day.